Well, hi, and welcome to Jim's Radio Shop. Continuing work on this Philco 91A. And if you watched the last video, you know it ended up with some smoke coming out of the radio. I had repaired and replaced the coil in here. When I was operating the set, it was not receiving the sound coming out of the speaker, but not receiving any signals. And smoke began to come out of some holes through the top, and I couldn't see exactly where it was happening here because I had the radio down. And I flipped it up, I did some temperature measurements, I put it back on to current limiting, ran it some more, let it heat up. And in the end, I believe that the smoke was coming from this mica capacitor. Let me, boy, it was hard to even realize it was there. Because it's so buried in there and dark. You know, once you know it's there, it's easy to find again. But let me put on my magnifier here. And we'll take a look at it. So, a little hard to read it here too. Okay, so there's the cracked resistor you're looking at. Just between it and this block, capacitor block, is a mica capacitor. There it is. And that appears to be the guy that was overheating and producing the smoke. Now, this is the oldest Philco I've worked on. I've encountered these blocks only once before. I didn't know a lot about it. So, off camera, I've been doing a lot of research here. I'm going down a journey I'm sure many of you have been down already. And one of the helpful things I got was this. Got this off the internet. It's a service bulletin, and it discusses these blocks. It talks about the old style and the new style, and it reveals what is inside all these blocks. And it's not that big a deal. I thought it would be a bigger deal, but for instance, in this style block, there's simply a capacitor connected there and a capacitor connected there. Just two capacitors. They may be the same size, they may be different. And the other style block is here. Well, it's got more lugs, but in many cases I think it only has two capacitors in it again. And there's all kinds of voltage ratings and values and combinations that you can imagine. That's what's generated all these tables, including a replacement guide for putting new blocks in where other old blocks that have been discontinued are, and that's what this part is. So there's a ton of information on this page. That's great. So this was a big part of me understanding what's going on in these blocks. Number two, I have the circuit diagram. You can see I've gone ahead and I've colored the high voltage wires to show all the lines that are involved in the high voltage. One of the things I learned, I didn't know this, is the high voltage goes right through the shadow meter, and I've already determined that the shadow meter on this radio has an open in the coil, and it looks like I'm going to be winding another coil soon. And of course with that open, you don't get B plus to the first two, and a couple others too. So a previous repairer chose to skip this out of the circuit. And that's just a little more about the shadow meter I'll be looking at, hopefully once I get the fire put out here. Now, you know, being a run-of-the-mill human being here, when I think of the two capacitors inside a block like this, the first thing I imagine is that they must be next to each other on the circuit diagram. That's pretty logical, but has nothing to do with the reality of it. It took me a while to figure this out. It took me quite a while. Oh, so part of doing that, in order to figure out all this wiring in here, I had to make this diagram. There's no way I could look at this and relate it back to the actual schematic. I had to do this as an interim step. So here you see I've drawn it out. That's these parts right in here. And it's a little hard to see in my diagram. Okay, well I apologize. My camera stopped again, and so I'm just going to repeat the last little bit. So this block appears here in my diagram. And there's this style I was able to find out by studying all this paperwork. Has two 0.05 capacitors in it. This one has already been abandoned. I can tell because this lead doesn't go anywhere. You kind of see it right here. It just doesn't go anywhere. Okay. So I know that guy's gone, and what he was doing was putting a signal ground on the B plus line, and here he is down here is his rebirth, if you like, is this capacitor, and that explains this wire in the air, which has been bothering me, because then I can now see that this wire used to be connected there. So now I can really see what happened. Even this wire, which is cut and taped here, which was kind of curious, and there's some slack over here, which is a little unusual. This wire was intended to run up here too. So this connection point used to be on this block. This capacitor used to be internal. No doubt, this capacitor failed. Had to be abandoned, so it's probably got a short circuit on it. Hey, let's put the meter on it. Let's find the meter. I have too much paper in here, man. I haven't got it covered up with paper. This will be kind of interesting. Let's just see what it reads. I saw what it read here. It's a short. So it's a shorted out capacitor in there. I had to get it out of the circuit. And so now, you know, there's no lug, so here it is floating in space out here. And something else I noticed, this is a 0.01 capacitor. And the one that was in there was 0.05. You know, that's quite a bit of difference. I don't think that's a good thing. I think that's too much. So I'll probably change this to a 0.01 and try to figure out a way to fix this in place. It's just not so good floating out there. I'm not sure if I can do that. So that answers a few things about this. Still doesn't tell me where this occurs in the circuit. So I studied this resistor, which is in parallel with the burning capacitor. I had to blow on resistor in parallel with burning capacitor. I mean, it kind of all goes together, doesn't it? And I wrote down the value on it. This is brown, green, orange. Or brown, green, orange. I think it would be 16K, and it measures 15.3K, even though it's all cracked up like that. It measures 15.3K. I couldn't find any 15.3K on the circuit diagram. But then I figured out by using another diagram. This one here, you know, I think anybody who works on Philco radios with any regularity knows everything that I'm going through right now. Because they just leave out little bits of information here and there, like the value of the component is not written anywhere. So he says with exasperation in his voice. So by using this, I was able to identify the part number of the block, number 13. So now the block doesn't appear in the schematic because the capacitors inside are not doing any kind of shared duty. They're not related to each other at all. They just happen to be two capacitors in a block with a ground on one side. And so, see if you can see the blue circles. The blue circles are the two capacitors on the circuit diagram. They have nothing whatsoever to do with each other. Okay, so once I saw the 13, figured out figured out the 13 over here, saw the 13 there, and spotted the 13 down here, which is pat me on the back for doing that. I then saw, hey, here's this resistor. Resistor 14. Okay, so if I look at resistor 14, it's brown, black, red. And this one is brown, green, orange. Huh. Okay. Brown, black. Did I read that right? 14. Brown, black, red. Well, why did I write down on my notes here brown, black, orange? Maybe I was a little excited. Okay, that's more different than I thought. So a brown, black, red would be a 1000 ohm resistor. And I mistakenly thought it was listing a 10,000 ohm resistor. I was thinking 10,000, 16,000. Okay, so the guy only had a 16K resistor. He stuck it in there way back when. I'm assuming this has been worked on. It kind of looks like it in here. And the resistor's smashed. So maybe that explains why that resistor didn't last. It was supposed to be a 1K, not a 16K. I wouldn't think that's why it would crack or overheat. Usually the other way around. You put in too low a resistor, you draw too much current. If the situation's right. Okay, so continuing on here. So this capacitor, I got the story wrong here, do I? Yeah, I have the story wrong. So this capacitor, oh my God. Help me, man. Okay, now I remember. Now I remember. So I then spotted this. Resistor 21. Okay, resistor 21. If I look at resistor 21, it's brown, black, orange. Yes, brown, black, orange. 10K, but instead there's a 16K there. Okay, so some guy did that. That's my guess. 10K, and the capacitor across it is a white yellow, and that's all it says, white yellow. And it doesn't mean a lot to me, white yellow. So I consulted with the god of the internet itself, and I discovered, I didn't print it out, I found a nice chart, and white yellow is a 700 picofarad capacitor. So I think that's what smoked. Hey, let's put the ohm meter on that guy. Hey, wait a minute, that resistor's in parallel with him and he's fried. He's shorted. Things aren't making 100% sense here. I'm on the 20K scale. Across the resistor. It reads $1965. Let me put up another scale here. Interesting. Very interesting. Okay, so on my home, no, you know what? of all the mistakes you can make. I've never made this one before. I'm thinking this is pointing up here on my meter, but in fact the pointer's down here. Boy, oh boy, oh boy. Let's try all that again. Okay. Okay, so we get 15.3 K ohms there. 15,000 ohms. And that's what I wrote down here. 15.3 K. So that resistor doesn't seem to be shorted. So another possibility is the capacitor, the remaining one that's still connected, this in the block. Maybe that one is shorted. Let's try that out. It's more like an open circuit here, which I guess is a good thing. Well, we're reading about 2 megohms. And that's not too good for a capacitor. Two megohms. Okay, I think the name of the game is we gotta. The overheating could have been in the block, and my ability to measure it may have led me to conclude it was outside the block in this capacitor. I think what we need to do is change this to the right side, right size. Get in the. Oh, wait a minute. What's this? This capacitor is a 0.05 bridging that other one. Okay, let's look on the circuit diagram again. It should be reading an open circuit there, or a proper capacitor. So I think the capacitor inside here is shorted. So let's pop this guy off. My guess is these blocks are a nightmare in these radios. That's my guess. So we're going to pop this guy off here. And there may not be any popping sound. It's not very hot here. What's going on? I just got no heat in my soldering iron. Let's crank it up a bit. Give it a moment here. So I'm thinking now I need to lift everything off this block, get everything off of it, remake all these connections. You have more airborne connections. Take the block out and put in a terminal strip. I'm not sure I have one. Terminal strip. Let's take a look at my box of goodies here. One of my many boxes of weird goodies. Man, it's not ringing a bell. Terminal strip. Yeah, I don't think I have any. That'll present a big problem. Because it's just too many wires to be, free connecting in the air in a radio like that. Not very good quality work. So maybe I'll end the video at this point. No, not quite yet. We really want to take this guy off here. And we should pop this resistor off. I'm going to do that with my fingers. Or we'll have something else smoking. It'll be me this time. I guess Philco thought this would be one of their secrets to success, having these capacitors in blocks. And there were engineering and design benefits for it. And there probably was. It's going to be tricky to get that guy out of there. He's in there pretty good. I'm in position to burn my fingers now in case anybody who does a lot of soldering would know that. I don't want to ruin this resistor. It measures good. Oh, look at how soft that's gone. It's just like goo. Ugh. Not good. I don't want to grab the body of the resistor. Don't want to snip it. See if I can pry the wire back a bit here. Keep heating this thing up. There's a lot of metal here, so I get it hot. It stays hot a long time. That lets the heat travel further. Not good. Okay, that's a little better. It's got it right around twice on there. That's no doubt that's factory wiring. Going to come off. Darn it. I have a container with about 50. Never used dog bone resistors. Original for someday when somebody really wants original parts. There we go. Now, let's put the ohm meter back on that baby. Let's see what's happening. We'll go right after it. I'm on the, I bent my voltmeter leads. I'm getting so a little too aggressive with it there. Okay, well that reads, yeah, going down. That would be, it's jumping around a bit, about 500K. Let's check this guy. Open circuit there. I know that resistor's good. This guy here, hey, there's a crazy low reading there. 0.09. Now we're going to change him out anyway. I'd be surprised if that guy's bad. Let's nip him out of there. We're going to redo this whole thing anyway, so we'll just nip that. Let's test him again. Now it's reading out. Getting a very low reading on the B plus line. What's going on there? Yikes. Don't like the look of that. Gotta find some more bad capacitors. reading open circuit now. I don't know what I was doing there. That's a short, of course. I don't know what's happening. It's reading open. Let's go up a little higher. Yeah, that's fine. But it's the wrong size. Okay, let's keep testing here a little more. Let's just go a little bit further. I'll look again at this. I think I was getting 15.3. I'm still getting exactly 15.3. Which is what this resistor would be. It's a 16K resistor reading 15.3. So why is something getting so hot? Am I forgetting what I did? Yeah, maybe I am. Yeah, it looks like the problem is internal to this block. So I think I'm going to stop at this point, and next time I could get at this radio, I'll do the actual installation of the newer capacitors here. Figure out some way to deal with the block, but I think the easiest way is it comes out, and in its place goes a terminal strip. Maybe I can find one in the meantime. So thanks a lot for watching. I'm certainly finding this very challenging. I'm learning some new stuff. Lucky I discovered a little more about how the shadow meter works. And check in again. We'll see you soon.